You know these things, right? You see it in a toolbox with all its crazy dials and ports, and you just think, nope, not for me. Well, we're going to change that. Today, we're going to demystify this little gadget and show you how it can become your new best friend for solving all kinds of electronic puzzles. I mean, we've all been there. You're mashing the remote control, you swap the batteries, and still nothing. Or you plug in your favorite lamp, flick the switch, and it's just dead. These are the little mysteries that drive us crazy. But what if I told you that you could find the answers in like 10 seconds with the right tool? And this is it, the multimeter. Seriously, stop thinking of it as some complicated lab equipment. Think of it more like a detective's magnifying glass for electricity. It lets you peek inside your gadgets and see what's really going on. And today, you're going to learn exactly how to use it. Okay, let's start with the absolute most common thing you'll ever do with this, measuring voltage. This is basically the power check. It's how you answer that question about whether a battery is actually good or just pretending. So what even is voltage? The easiest way to wrap your head around it is to think of it like water pressure. You know how water pressure is what pushes water through a hose? Well, voltage is the push that shoves electricity through a wire. If you don't have any push, you don't have any power. Simple as that. Now, on your multimeter, you're going to see two main types of voltage. First, there's DC, or direct current. That's your battery power, everything from your car to your camera. The symbol for that is a V with a straight line over it. Then you have AC, or alternating current. That's the heavy-duty stuff coming out of your wall sockets, and its symbol is a V with a little wavy line next to it. All right, let's test a real battery. First things first, your black probe always goes into the jack labeled COM. That stands for common or ground. Then your red probe plugs into the jack with the V next to it. Now just turn the big dial to the DC voltage section, the V with the straight line. You want to pick a setting just a little higher than what you expect. So for a 1.5 volt battery, you'd pick the 2 volt setting. Finally, touch the red probe to the little plus sign, the positive end, and the black probe to the negative end. And boom, you'll get a reading. If it's near 1.5 volts, you're good to go. But if it says something like 1.2, yeah, that battery's toast. Whoa, hold on. Before we go any further, we have to talk about safety. This is super important. The voltage in a little AA battery, totally safe. You can't hurt yourself. The voltage in your wall socket, that is a whole different story. It is absolutely dangerous. So when we start talking about measuring that, you need to be 100% focused. Double check everything before you touch anything. Okay, ready? For a standard US wall socket, you're going to turn that dial to the 200V setting in the AC section, the one with the wavy line. Keep your fingers way back from the metal tips of the probes. Now you carefully slide the black probe into the bigger vertical slot and the red probe into the smaller one. You should see a reading somewhere around 110 to 120 volts. If you see 0, you've probably just got a tripped breaker. Awesome. You now know how to check for power, which is half the battle. So let's move on to our next big topic, checking the circuits themselves. This isn't about the power source anymore. It's about making sure the electricity has a clear path to travel. We're checking the flow. And the first way we check that flow is by measuring resistance. The symbol for that is the Greek letter omega, and it's measured in ohms. Resistance is exactly what it sounds like. It's how much something fights against the flow of electricity. Every little component on a circuit board is designed with a specific resistance. If that number is wrong, you found your problem. So to measure it, you just turn your dial to the resistance section marked with that omega symbol. Now, here is the golden rule. You cannot break this rule ever. The circuit you are testing must be completely powered off. Unplug it from the wall, take the batteries out, whatever you have to do. Testing resistance on a live circuit just doesn't work and can even be dangerous. Once it's dead, you just touch the probes to each side of whatever you're testing. Okay, now for what is maybe the most useful, most satisfying feature on your entire multimeter, the continuity test. This is the simplest test in the world. It's a straight-up yes or no question. Is there a solid, unbroken path for electricity to get from point A to point B? It's like checking to see if a road is open or closed. The multimeter does this by sending a tiny little electrical signal down the wire. But the coolest part is, you don't even have to look at the screen to get your answer. It beeps. How great is that? You hear that nice, clear beep, and you know you have a complete connection. If you hear silence, well, that means there's a break in the line somewhere. It's the ultimate aha moment when you're troubleshooting. So what's this good for? Oh man, everything. It's amazing for finding breaks inside of cables that look perfectly fine on the outside. And remember, always unplug the device first. Just touch one probe to one end of a wire and the other probe to the far end. No beep? That wire's bad. Pro tip, you can even wiggle the cable around while you're testing to find those super annoying problems that only happen when the cord is bent just so. All right, you're doing great. We've talked about the electrical pressure, which is voltage. We've checked the pathways with continuity. Now it's time for the final and most advanced measurement, current. If voltage is the push, then current is the volume of electricity that's actually flowing. We measure it in amps. Now, this is where you have to pay really close attention. To measure current, you actually have to move your red probe out of the voltage port and into one of the special amp ports. There's usually a low current one for small electronics that's protected by a fuse and a high current one that's often not fused. You have to be really careful here. If you try to measure too much current through the wrong port, you can literally blow up the fuse inside or even destroy your multimeter. So measuring current is totally different from the other tests. You don't just touch the probes to something. You have to make your multimeter part of the circuit. This means you have to physically break the circuit open, usually on the power wire, and put the meter right in the middle of it. The electricity has to flow from the battery into the red probe, through your meter, out of the black probe, and then onto the rest of the device. I know. That was a ton of information, but you made it. To help it all stick, we've put together a little quick start guide. This is definitely the slide you want to screenshot and save to your phone for later. It's your cheat sheet. And here it is, everything in one spot, see? For DC voltage, AC voltage, resistance, and that awesome continuity beep, your probes stay in the same place. Red in the V port, black in CALM. Easy. The only time you move that red probe is when you're measuring current, and it has to go into one of those A ports. Just remember those key safety tips. Be crazy careful with high voltage. Never, ever test resistance on a powered-on circuit. And remember that for amps, your meter has to go right inside the circuit. So, there you have it. That thing that looked so intimidating an hour ago, it's not a mystery anymore. It's a tool, and it's in your hands. So go find that junk drawer full of questionable batteries, or that flickering lamp, or that toy that stopped working. You've got electronic superpowers now. The only question is, what are you going to test first?